Hello guys, let's learn about derivatives in machine learning in AI. Hopefully you watched the functions lesson, you know what functions are. So derivatives, let me say, are rate of change of the function. So what does that mean? First of all, derivatives are used for the neural network to learn. So neural network is learning through finding derivatives. Just to show you how important they are. And here, this is the function, this is its derivative. So you see that derivative is 3. So for any x, derivative is always 3. So that means here, if you move by 1 on this function, so you move x by 1, y will move by 3. So actually this is not so precise, but I will explain why it's not precise, but let's just understand it this way. So if you move by 1 on x, you will move by 3 on y. So let's see. X is 5, okay? And if we go from 0 to 2, so from 0 to 2, that's moving 2 by x by 2. So that should move y by 6. So then this line goes through 5 and should go through 12, and it does. So maybe this is actually written weirdly. Nevertheless, this is going through 12. So that's what it means. That's what derivative of 3 means. It means if you move by x by 1 unit, you go 3 units up on the y-axis. So why did I say it's not completely accurate? Because this is just showing the change just around this x. So if you look at x0, this 3 means it's changing by 3 just a little bit around x. So if you move by whole 1 unit or 2 units, that could have completely different derivatives. So that could have completely different slope. In this case, slope is everywhere same. So in this case, we are lucky. So in this case, if we move far away, the slope is still same. But it doesn't have to be. In this other example, you can see that here, derivative at 0 is actually, so it's almost flat. So here derivative should be 0. So it is, look, where x is 0, the value of the derivative is 0. So we have flat, okay? But where x is 1, the value of the derivative is 2 already. So here the slope is already 2. So here, just around this point, if you move a little bit by some unit, a little bit, on x-axis, the y-axis will go 2 times that same unit up. So that's why I don't want to say like if you move by 1, because if you move by 1, then the derivative will be different, completely different. So if you move a little bit, like just a little point, then there's a derivative there. So you see that as we move, for example, at 2, the slope, the derivative is 4. So this is why it's quadratic function actually. So here it grows exponentially, it grows more and more. Anyways, whenever you are learning these things and learning with me, ChatGPT is your best friend. So any questions you have, ChatGPT, or you can comment below. I will try to answer as soon as possible. But ChatGPT, use AI as your personal teacher. And I said it grows exponentially, but I should say it grows quadratically, not exponentially, to be more precise here. But it still grows very fast, is what I'm trying to say. I actually have a very nice example here. So, if you are driving a car and you just take a picture of the car, from that picture you don't know what the speed of the car, if you don't picture the speedometer, but you just take the picture of the car, you don't know the speed of the car. So how do you figure out the speed of the car? So that's kind of the issue that derivatives are trying to solve. If you just have one point at a function, how do you know how quickly the function is growing at that point if you don't have another point? You don't have like 2 points. You just have 1 point. And that can be done from the formula of the function. So here are some derivation rules. Now you will not manually calculate derivatives like this. You don't need to know these rules in day-to-day life. But this is one of those things when parents advise their young children learn a foreign language, you'll need it in the future. And child asks, why will I need it? What will I need it for? And the parent doesn't know because You never know. And always, like, those people always say it's good that I learned foreign language. So it's gonna be very good for you to learn derivation rules, even though it's gonna be good in the future. I don't know when and how, but if you want to understand like deep theory behind neural networks and be like the best researchers who really understand the theory, then you need to understand derivation rules. Okay, let's see. The first rule, if you have x to some n, so here x is the unknown, you see here x is the unknown. So derivative of here is you put this exponent before x, so 3 times x, and reduce exponent by 1, so 3x squared. So derivative of x to 3 is 3x squared. So if you have 4 times x to 3, then derivative is, so this remains, this 4 remains, and then you just do the same thing with the exponent. You put exponent before and here reduce by 1, so this is the derivative. So if you, so whatever x you have here, if you have some point here, you can put that x into the derivative and get how quickly the function is rising or changing or at that point without having to have different points, just that single point. So it's like calculating a speed from a car just from a single image where there is no way to know the speed. I actually have those step-by-step explanations. If you want, you can go. I recommend you go. So did you also know when you have square root of x, that's same as having x to the power of 1/2. So that's the same thing. So derivative of this would be like, rule would be same. So you place this in front of x, so this times x, and then subtract 1. So when you say 1/2 minus 1, the result there will be minus 1/2. And if you have x power minus 1, you put minus 1 before, you subtract 1 from the exponent. So this is exponent. You see this means that this is the power, the exponent. So you will get minus x to the power of minus 2. And if you didn't know, if you have like x to power of minus 2, that's same as 1 over x squared. So look at this, look at this. This x power minus 2 is equal to 1 over x power 2. And then we have this minus that comes from this. So these are just some math rules. These are things that are good to know and that you will need in the future. I recommend you practice this. You try to explain this yourself. You try to repeat. You can put this into AI chatbot and tell it to explain to you again. And you can rewatch this video, my explanation. So constant multiple rule, I actually already explained. So if you have some constant, some number, up here we had number 4 times this. So the derivative of this, you just like, it remains 4 times whatever you do. So it just remains 4 times, and then you find the derivative of this other thing. So the constant rule is that when constant is inside of this, multiplying this x, the unknown, there is a better name for it, but I cannot remember. The constant remains, the number remains, and then you find the derivative of the thing, of this function, whatever it is, or the rest of the function. We can see examples. So 5x squared. So the rule is 5 remains the same, and then the derivative of x squared is 2x, according to the previous rule. So in the end, it's 10x. So 5 times 2 times x, it's 10x. I got more examples. I recommend you go through them. Try to calculate this yourself first, and then look at the examples. Then we have sum rule. So if you have like here x and here x, you want to find the derivative of the whole thing, you just find the two derivatives separately. So because there is a plus here, it means like just find this derivative separately, this derivative separately. Okay, so let's see example. How do we find the derivative of this whole thing? Okay, so basically we just find the derivative of this and we say plus derivative of this, and that's it. And you can see here, well, this is going to be 2x, and this is gonna be just 3. Derivative of this is just 3 because, okay, this is a homework. Why is the derivative of this just 3? I'll tell you, because you put this 1, because there is this is x to power 1. You put it before the x, and then you subtract 1 minus 1, the exponent. Subtract 1 from the exponent, you get 0. So x power 0 is actually equal to 1. Okay, I'm leaving this for your exercise. Here we have same example. So look at this. If you have a lone number, then this becomes 0. Okay, so look at it this way. If constant is next to our unknown x, then that constant just remains 5 times whatever the derivative of this is. But if the constant is alone, that it becomes 0. So this becomes plus 0. The derivative of a constant is 0. You can see here. This just requires practice. So this is actually quite easy. For me, it's easy because I learned it. So for you, it might seem like it's impossible. I'll never understand it. There are so many rules. It's so easy. There is like 2 or 3 rules. And now I put more examples here. So product rule. If you have something times something, and both of these elements contain x, so then this is the derivative. So you find derivative of the first times this without the derivative. You see, this is derivative, it says here, plus no derivative, so just repeat this, times derivative of the second one. Okay? You can see how it works here. So to help ourselves, we will first find derivative separately, the derivative of this and derivative of this. So that's gonna be 2x and 1. So derivative of this is 1. Why? Because this becomes 0 and this becomes 1 because it's x power 0. So this is the previous rule that I told you to practice. Anyways, so we just repeat. So we find the derivative of the first one times second repeated plus first repeated times derivative of the second one. So that's the rule. You need to sit down and just practice this because it's difficult for me. Like, I cannot inject this knowledge into your brain. If I could, I would, but I can't. Chain rule. This is how backpropagation works. This is how neural networks learn. So you have one function and inside another function. So for example, you have here x squared plus 1, that's one function, and outside is all of that result power 3. So the way you do this is a chain rule. So you first do derivative looking at this whole inner function as x. So imagining this, so whatever you do to x, you will now do to this whole inner function. So let's show you with an example. So I told you we have x squared plus 1 power 3. So here we will put this 3 in front of this bracket as if this whole thing is x. So we'll put this 3 in front and subtract 1 here. So then that would be 3 times this in brackets power 2. Because at first we look at this as just x. And then we say times derivative of this, which is gonna be x. Oh no, it's gonna be 2x. This is derivative of this is 2x. So these things just require practice and careful reading. But this is very important. This is the chain rule. This is how we calculate gradients and how neural networks learn. And then also, sometimes there are some special functions or functions that have their own derivatives. So if you have this function, how would you derive? I wrote step by step, but usually you would just Google this or ask ChatGPT. So this is the... Oh, wait. It's right here. So I guess this is the final derivative. It's a bit weird. But usually... and because you'll notice that this part is actually same as our function that we are deriving. So this is actually, it turns out accidentally that this is the function that we are actually deriving, it's contained in its derivative. It's kind of weird. So that's why they replace that with f of x. So that's kind of interesting. And then you can do some like math tricks to also replace this with 1 minus this f of x, which f of x is our sigmoid function. So yeah, this is some weird math tricks. It's interesting. And all of this requires a long time of practice. So you don't need to master it right now. Like watch this video, see what you can do, go on to the next video. You will learn this over like months, years, whatever. This can be like a secondary thing you do. Or if you want to work like neural networks optimizers, then you're gonna be learning this faster. Partial derivatives are same as derivatives. The only difference is that instead of one variable, x, you have two variables. So what you do here is you find partial derivative of this function with respect to x, and after that you find it with respect to y. So what does that mean? It means you find derivative of this imagining that y is a constant. So just as if this x is your variable and y is constant. So this constant will become 0, this constant will become 0. You just find derivative of this. Okay, so that's the partial derivative of this function with respect to x. Okay, and partial derivative of this function with respect to y means you imagine that x is a constant. So as if this is a constant. So this will become just 0 because this is a constant. That's derivation of constant is 0. So you then just find the derivative of this because these two constants are 0. And this is used a lot in neural networks, in backpropagation. I explained this step by step. So you just treat y as constant, you imagine, and then, yeah, this is the whole thing. So actually this is very well explained. This just means partial derivative of this function with respect to x. So that's what this notation means, even though it kind of looks weird. So this just means imagine y as constant and find derivative of x with respect to x. And here we got to the end. That was a little bit dense lesson, I believe, but you have everything here. I'm gonna make this video and see you in the next lesson.